This is the first of two videos for section 1.6. The section is called Modeling with Intercept and Slope. So it's really just a couple of story problems. This first video, we're going to do a story problem or application problem review from things you've already learned. I'm going to then give you a bunch of vocabulary that we're going to start using, trying to use working into when we talk about math. Having some shared academic vocabulary makes discussion a lot easier. Then the second video today will be one more example, and that will be it. Here we go. All right, so this warm-up, you have all the skills you need to solve this problem. It says each swing of a pendulum is 3 inches shorter than the preceding swing. The first swing is 6 feet. Problem 1, they want us to write a recursive and explicit rule for the length of each swing. So recursive is like the long cut, and explicit rule gives us a shortcut. And then we're going to find the total distance the pendulum has traveled after 5 swings. Okay, cool. So one thing, I have it highlighted in green. I give you a hint to think about this. How many inches are in a foot? Why would we care about that? Is because if you go back up to the problem, it says each swing of a pendulum is 3 inches shorter than the preceding swing, and the first swing is 6 feet. It is difficult to work in different units, having some information in inches, some information in feet. So I'm going to just change it over to inches right now. We know there are 12 inches in a foot. So we're going to do 6 feet times 12 and acknowledge that the first swing was 72 inches long. All right? So the recursive rule, it says the first swing is 6 feet, or the first swing is 72 inches, because we're going to work in inches. So I think it would make sense to call u sub 1 72, because it was the first swing. And then what will happen is it gets 3 inches shorter each time, so that's a nice arithmetic that you'll take the value of the previous term and subtract 3. So there is your recursive formula. If you want more of an explicit one, the recursive one is super helpful. Remember, that gives you the slope, and then we can quite easily find that y-intercept. So I've got a slope of negative 3x, and then what's my y-intercept here? If my first swing is 72 inches, my second swing, it'll be 69, 66. Well, I need the 0th one, which will sit at 75. I recognize that a 0th term does not always make sense in real life, but you need it for that explicit rule. And now that I've written the rule in a way I'm comfortable with, I'm going to replace the y with the u sub n and an x with the n to get it to be truly explicit. Now the textbook would write it as u sub n is 75 minus 3n. You decide what feels best for you. Problem 2, what's the total distance the pendulum has traveled after 5 swings? Well, I know on that first swing it was 72. Second was 69. I already did some of this above. Third swing was 66. Fourth was 63. Fifth swing was 60. Now, some of you are like, Miss Milton, why don't you just do the explicit formula and plug in to get that 5th swing and get the 60 right there? That's how you could have jumped to that 5th swing. But why in this problem is it important to have all 5 of these data points? Because it's asking for the total distance. So what we actually have to do here is add up all 5, which I believe gets us to 405 inches is the distance it has gone in 5 swings. So sure, it was nice to do the shortcut to get to that 60, but this one required we had all the in-between values as well. So the recursive actually came in handy for us here. All right, this next slide, I highly recommend you write all of this down in your notes. Try to take as neat of notes as you can, because we're going to be talking about these terms a lot now. Independent variable, dependent variable, domain, and range. And basically, these terms are going to help us talk about when you have relationships between 2 variables. The first term's value is 7. The second term's value is 14. There's a relationship there, and we want to be able to talk about it. So to do that, our dependent variable, I'm actually going to start with dependent variable. That is the variable that happens no matter what. It's independent. It doesn't rely on anybody or anything or any other information. It just kind of, it is what it is. It happens no matter what. A really common independent variable in story problems is considered time. Why would time be considered an independent variable? Because time passes on regardless. The seconds march on, the days march on, the years march on, no matter what we do. It still happens. Time goes no matter what. It doesn't depend on anything. So then a dependent variable, maybe you're guessing it does not happen no matter what. The dependent variable is the variable whose value depends on something else. The information, it depends on the other one. It's going to depend on the independent variable actually, okay? So it makes sense. Independent variable happens no matter what. The dependent variable, well, its value depends on something else. It depends on that independent variable, okay? The idea of the domain is a set of possible values for the independent variable. The domain is a set of possible values for the independent variable. There's a reason I wrote domain underneath independent variable. Those match up. They are most oftentimes considered your x values because they tend to sit on the x-axis. When you graph things out, your independent variable goes along the x-axis. Where the range, I wrote it over here underneath the dependent variable because it is the set of possible values for the dependent variable. Oops, sorry. So I wrote the range underneath dependent variable because they match up together, and they will be considered your y values. When you graph them, they sit on the y-axis. All right, so far we've got 4 terms. Independent variable and domain match together. Dependent variable and range match together. Maybe I should make those a different color. Like that. Now let's do some examples where I think it will all come together. Let's start by talking about a road trip. All right? You're going to get in your car and you're going to go drive to Florida or California or Iowa, wherever you're going to drive to. It makes sense to me that, remember, you've got your x-axis and your y-axis, and it makes sense to me that time that you're in the car is your independent variable. The time will march on whether you're driving or not. No matter what you're doing, time ticks by, okay? So time is our independent variable. It happens no matter what. Happens regardless. Where the distance your car travels, well, that depends how much time you've spent in your car, how much time has passed, okay? So if you can be like, if your friend calls and says, oh, how far have you gone? Well, that answer depends on how long you've been driving in the car. So that's why the distance the car travels goes on the y-axis. It's considered your dependent variable. It might be worth writing down because the distance the car travels depends on time. So then what happens is the values that X could be, maybe we're talking in hours, or a really long trip you're talking in days, or a short trip you're talking in minutes, but those values, that's considered your domain. So domain is like when you're graphing something, it's the numbers you put on your X-axis, where the range are the numbers that go on your Y-axis. Usually, you know, here in the US, distance would be considered in miles. So it would be the possible values. Maybe the range would make sense to be 0 to 20 miles if it's a short trip, or maybe it's 0 to 1,000 miles you would set your range at if it's a longer trip. So the range are the values that make sense for the y-axis, your dependent variable. Let's go back to that good old hot cocoa. See if you can kind of figure out what's going on with hot cocoa. The temperature of the hot cocoa depends on the amount of time it's been out of the microwave. So again, time is your independent variable. I think time for hot cocoa, when it makes sense to measure it in hours, I think it would make more sense to measure it in minutes. So that is your independent variable, where the temperature depends on time. So the temperature is your dependent variable. It'll probably be in like degrees Fahrenheit. So I'm going to put that on the y-axis, and I'm going to write down, to just make it clear, the temperature of the cocoa depends on time outside of microwave. So that depends on, the temperature depends on, so it's the dependent variable. And then I think it would make sense, remember your domain values are the possible X values. So I would say the domain could be like from 0 to 10 minutes, where the range are your possible Y values. Remember how we talked about in the long run, the hot cocoa will settle out at room temperature, so maybe about 70 degrees. So I don't know, maybe the list of possible range values would be 70 and up. Who knows how hot your hot cocoa is going to get. The last thing I want to talk about on this is the idea of domain and range, how you can write about it. In both of these graphs, quadrant 1 seems to make the most sense. So with graphs like this, we'll be sticking mostly in quadrant 1. And then a way to write about domain and range, well, let's look at the distance the car travels. What would make sense for X values? What would make sense for your domain? Well, I would say it's when the time is greater than 0 hours. So I would say X is greater than or equal to 0, because it might be worthwhile to know that at 0 hours you've gone 0 miles, so greater than or equal to 0. It doesn't make sense to have negative values. You're not talking about negative time, that we're driving for -2 hours, like you wouldn't ever say that. And then it makes sense for the range, Y, to be greater than or equal to 0, because the distance your car travels, you could travel 0 miles, you can be sitting in the parking lot, or you can travel 10 miles, 20, but you're not going to say you traveled -10 miles. No one talks like that. How about the cocoa? Quadrant 1 makes sense, so I'm going to say my domain, the time, I'd say X is greater than or equal to 0 in minutes. We're not going to look at what the temperature is at -3 minutes. And now here's where you could get a little creative with the range. You could just say, oh, I want to know when the temperature is greater than or equal to 0. But I think you could narrow that down a little bit more and say, we kind of care about what's happening when it's greater than or equal to 70. Because if you look, all your data points are going to be at or above 70. You're not seeing anything in here, so you wouldn't include that in your range because you just know you're not going to get any data points around there. So that is how you can write about domain and range. Please, this slide, take a minute, look back at your notes, rewind the video if you have to. You need to make sure you have some good notes here because you need to start using the idea of independent, dependent variables, domain and range, and being able to write about them kind of in this fashion here and here. So make sure you've taken good notes. Pull out your highlighter. Highlight some things that you think are important to you. And that is it for this video. Thank you.